Sorry. Welcome back everyone. Going to go over ionic equations today. So the first one, when you have sulfuric acid combining with sodium carbonate, okay, that gives the salt sodium sulfate plus water, okay. I did this and the video went wrong, so I'm redoing it. I ran out of memory stick. So it gives sodium sulfate plus water plus carbon dioxide. Yeah, so the sodium combines with the sulfate to form sodium sulfate, and the hydrogen combines with the carbonate to form water and carbon dioxide. Okay. When you can write this out as an ionic equation, which are down here. So when you do that, you get the two hydrogens here, plus, which are in aqueous solution, plus the sulfate ion, SO42 negative aqueous, plus the two sodiums in aqueous, that's 1 plus the carbonate ion, CO32 minus aqueous. That goes to a product, the two sodium ions plus the sulfate ions plus water plus carbon dioxide. So there's something called spectator ions in this, which is, the ions are crossed out in fact. When you look at this, you've got the sulfate and sodium ions on both left and right hand side of the equation, whereas the hydrogen ions and the carbonate ions are not on both left and right hand of the equations. In the reactants you've got hydrogen and carbonate ions, and the product you've got water and carbon dioxide. So the hydrogen and carbonate have undergone a sort of major chemical change and structural change and turned into water and carbon dioxide, whereas the ions, the sulfate and sodium ions, haven't. And that's why they're called spectator ions, because they're a bit like the fans of a football match or a cricket match or something, a rugby match. They're watching the game, but they don't actually do anything apart from watch. They're not taking part in the actual game. These ions are doing the same thing. They're not taking part in the actual reaction, although they do form sodium sulfate, but they're not undergoing, the ion still remains as sulfate and sodium. Okay, so that's an ionic equation. When you cross these out, you get left with the two hydrogens plus the carbonate becomes water plus carbon dioxide. So that's an ionic equation. Simplified, that's with all the ions present, okay? And next example, I've done this the wrong way around actually, but it doesn't matter. So this was the first page, doesn't really matter. Ionic equation, so the next example is nitric acid plus lithium hydroxide becomes the salt lithium nitrate plus water, okay? If you write this out as an ionic equation, showing all the charges involved, like I did before, you got hydrogen plus nitrate ion, NO3 minus, which are aqueous, plus that ion, the lithium ion aqueous, plus hydroxide ion aqueous, goes to the lithium ions plus the nitrate ion plus water, okay? So again, nitrate and lithium ions are on both sides of the equations, therefore they are spectator ions. Although in here, obviously you get the lithium hydroxide and nitric acid and lithium nitrate, so it's not obvious here what's going on. But when you lay it out like this, you see that the nitrate and lithium, they do not change, they remain as a nitrate ion and lithium ion on both sides, both in the reactants and products. That's why they're called spectator ions. Whereas the hydrogen combines with the hydroxide ion to form water. Okay, so they actually do undergo a change. Water is the molecule that's present as a liquid, okay, and the lithium here and nitrate are dissolved in the water, okay. So that's what the spectator ions are, and when you cancel them out, which I didn't actually do when I was doing that, so if you cancel them out, you end up with hydrogen plus hydroxide becomes water. So that's the This is the ionic equation showing all charges involved, and this is the overall reaction of hydrogen ion plus hydroxide forming water. Okay, so that's ionic equations.